In today's class, we are going to learn about oxidation, reduction, and what is a redox reaction, okay, with lot of examples. Let us consider, I would like to take up this concept in terms of examples, and then we will, at the end, we'll try to define what is oxidation, reduction, as well as redox reactions, okay. Consider this example. When copper reacts with oxygen in presence of heat, it forms copper oxide. In this reaction, it is very much clear that oxygen is getting added to copper. Addition of oxygen is known as oxidation. Not only that, we also see that copper is forming CuO. That means copper is oxidized. It is a very popular terminology to be used in oxidation reduction reactions. Copper is oxidized to CuO. The same observations I have written here. Yes, there is addition of oxygen to the substance. Yes, and copper is oxidized to copper oxide. Now let's move on to the next equation. Copper oxide reacts with hydrogen gas in presence of heat and it forms copper plus water. Now what are we saying here? Copper is being removed from, oxygen is removed from copper oxide and it is forming copper. Removal of oxygen is known as reduction. We know this definition, isn't it? Yes. And we also say that CuO is reduced to copper. Now, have a look. Yes, these are the two things which is happening in this equation. There is a removal of oxygen from copper oxide and the copper oxide is reduced to copper. Let us take up now another example where I'm trying to show you the oxidation as well as reduction taking place simultaneously. Yes, CuO plus H2, okay, forms Cu plus H2O. CuO to Cu, it is reduction because there is a removal of oxygen from the substance. Whereas hydrogen to H2O, that is hydrogen to water, there is addition of oxygen taking place. Okay, so therefore this is an oxidation reaction. This is a reduction reaction. Together, this is an example of redox reaction. Now let us proceed with some more examples. The hint is try to focus on role of hydrogen. Okay. When hydrogen and chlorine gases react in diffused sunlight, they form hydrogen chloride. This is the result. Now, what is being done here in terms of hydrogen? If you look, is addition of hydrogen taking place? Yes, addition of hydrogen to a substance. Addition of hydrogen to a substance is nothing but reduction. Yes, right. And then the Cl2 is now forming HCl. So chlorine is reduced to HCl. Okay, let's move with the next example. H2S plus Cl2 forms HCl plus sulfur. Now, where is the addition of hydrogen taking place? To chlorine? Okay, we can say that. Now, look in terms of removal of hydrogen. Okay, hydrogen is removed from H2S and it is forming S. Removal of hydrogen. What do you call removal of hydrogen? Removal of hydrogen is nothing but oxidation. So therefore we say this, H2S is oxidized to sulfur. Now let us see this equation. H2S plus Cl2, HCl forms HCl and S, that is sulfur. When you see this, I say it as H2S getting converted to S. There is removal of hydrogen, therefore it is oxidation. Cl2 is getting converted to HCl in the reaction. So what is being added? Hydrogen is added. So addition of hydrogen is reduction. Remember, removal of hydrogen from a substance is oxidation. So oxidation, reduction simultaneously is shown in this equation. This is an example of a redox reaction. Now let us see oxidation and reduction in electron concept, that is loss of electrons, gain of electrons, how it proceeds with examples. For this to understand, take an example of the equation. When sodium and chlorine are fused together, it forms sodium chloride. Okay, do you all remember this? Ion formation. When sodium atom loses its electron, it forms sodium ion. Similarly, I can write this equation as simple. This minus electron, I'll send it to the other side of the equation. Okay, other side of the chemical equation. Then it allows me to write like this. Sodium forms Na plus other side it has traveled, so plus electron. This is nothing but oxidation. Consider this as equation 1. Okay, now for explanation of chlorine, chlorine picks up that electron which is lost by sodium and converts itself to chloride ion. So this is reduction. Something is striking to us? Yes. Loss of electrons is oxidation. Yes, we already know that. Gain of electrons is called as reduction. Now, combine equation 1 and 2. Combine oxidation and reduction reactions. So the net result of the redox reaction is going to be like this. Repeat the step written in oxidation reaction. Repeat the step written in reduction reaction. Write it. Now you see the electron on the right hand side of the equation and the electron on the left hand side of the equation. Okay, it needs to be in the opposite direction, gets cancelled. When this gets cancelled, whatever is left, we write it, that becomes the redox reaction. So Na plus Cl forms Na plus, and Cl minus is existing here. There is no plus sign. So these two different charges combine together and form NaCl. Thus, this is an example of a redox reaction in terms of electron concept. Example where we all can see evidently oxidation and reduction in terms of electron concept. Okay, Cu plus O2 in presence of heat forms CuO. When I balance, I get 2Cu plus O2 forms 2CuO. Okay, how do you explain this formation of CuO? These were elements. Before forming the compound CuO, copper and oxygen were elements. So we consider like this. And this compound CuO is formed by the attraction between Cu2 plus ions and O2 minus ion, which we call it as copper ions and oxide ions. These two combine and form CuO. So we are trying to explain how this Cu2 plus and O2 minus ions exist during the reaction. Cu is converting itself to Cu2 plus. This is nothing but loss of electrons. Loss of electrons is oxidation. Before this 2 plus, it was a neutral atom. The indication is a 0 on the top of the metal I have put. Now, similarly, the oxygen atom also, which is neutral, picks up 2 electrons, which is lost by the copper, and converts itself to oxide ion. So what is a gain of electrons? Is nothing but reduction. This can be understood, or it is expressed in a better way, the oxidation and reduction, in half reactions. Half reactions are nothing but splitting the redox reactions and showing oxidation and reduction reactions in terms of electrons. Such reactions are called as half reactions. So I'm taking the same example. Cu forms Cu2 plus 2 electrons. That is, it has lost, it has given away, it has spit out its electron from its atom to form this Cu2 plus ion, which is an oxidation. Similarly, the 2 electrons which are given by copper is being used by oxygen to, it gains 2 electrons and becomes O2 minus, that is oxide ions. So gain of electrons is reduction. It's evident even in the equation, gain of electrons, reduction. Combining 1 and 2 to get a redox reaction, Cu plus, before that, the 2 electrons on the right hand side and the 2 electrons on the left hand side gets cancelled. On combining, you get Cu plus O. These are the 2 reactants forming Cu2 plus and O2 minus. They attract each other and form CuO compound, copper oxide compound. Another example of redox reaction can be considered in this example, the reaction between zinc metal and copper sulfate solution forming, after some time it forms zinc sulfate and copper. Okay, you already know this reaction. When copper sulfate crystals are put in water to form a solution, it splits into Cu2 plus and SO4 minus ions. The zinc metal is remaining. The reaction is between these now. Okay, the reaction is between this. Now what happens is zinc, which is a metal, loses its electrons and forms zinc plus 2 ions will be there in the solution. And then this is already split. The zinc 2 plus is more reactive, so it reacts with SO4 minus, forms zinc sulfate, okay, and copper, the 2 electrons which are lost by zinc is picked up by copper to form Cu. So there is a loss of electrons by the zinc metal to form Zn plus 2, which is oxidation. Cu2 plus forms Cu by gain of electrons, which is a reduction. Therefore, this can be understood in half reactions. Zn gives Zn2 plus 2 electrons, which is oxidation. Always in oxidation, we put it plus 2 in the product side. Good. That's another observation. Cu2 plus 2 electrons. If plus or addition of electrons are shown on the left hand side, it is reduction. So when Cu2 plus 2 electrons form Cu, then there are in these 2 equations, you have 2 electrons on the right hand side, 2 electrons on the left hand side, which gets cancelled, and you are left with zinc plus Cu2 plus forms zinc 2 plus and Cu metal, which is formed here, Cu plus metal. So zinc is getting converted to zinc 2 plus due to loss of electrons, which is called oxidation. Cu2 plus gains the 2 electrons and gets reduced to copper. So how do you read this? Zinc oxidizes to zinc ions, copper ions reduces to copper metal. This is what is happening in this redox reaction. This is a very famous way of remembering. Either of the two are very famous. You can understand it. OIL, the mnemonics or the abbreviations. OIL, RIG, oil rig. You must be knowing drilling of oil from the underneath ground is called as rigging. So oil rig. Okay. It's a notation of oxidation is loss of electrons. OIL, oxidation is loss. So I have taken it as OIL. Rig stands for reduction is gain of electrons. If this is not very familiar to you, you can go with a very familiar one, LEOGR. Leo, it stands for, the abbreviation for this is loss of electrons is oxidation. Here you have even the oxidation very clearly shown. Loss of electrons, oxidation, gain of electrons, reduction. Okay. Whatever we have discussed, okay, this can be understood thoroughly to define oxidation and reduction reactions. Addition of oxygen or removal of hydrogen from a substance. In terms of electronic concept, loss of electrons by an atom or ion is called as oxidation. I repeat, addition of oxygen or removal of hydrogen from a substance, or oxygen being added to a substance, or in terms of electronic concept, loss of electrons is nothing but oxidation. Whereas reduction, addition of hydrogen or removal of oxygen, and in the electronic concept, gain of electrons. All these can be used to explain in the given equations whether it is an oxidation or reduction, whichever is convenient to you, depending on the situation given to you. This is all about oxidation and reduction, and I want you all to try out how much you have understood in today's class. Try out question 3 and 4. Do it in your classwork. Thank you.